In this lesson, we're going to review what complex numbers are, how to find powers of the unit of complex numbers, how to add, subtract, multiply, and divide them, and also how to solve equations in what those equations look like in the world of complex numbers. Recall that complex numbers arise from trying to solve this this sort of equation, where this relatively simple and innocuous equation, x squared plus 1 equals 0. And on the face of it, this is a pretty straightforward equation. It should have solutions, but if you try to solve it, you get something like this. You get x squared equals negative 1. X is equal to plus or minus the square root of negative 1. This doesn't have solutions in the real plane. However, mathematicians in the 1700s and into the 1800s realized that there are plenty of examples where it's fruitful to try to solve equations that where this sort of number arises. And when you do so, entirely new branches of mathematics open up, and things that are extremely applicable to modern technology and modern society. Electrical engineers solve equations with imaginary numbers all the time. That's how people have understood how electricity works and so on and so forth. So these aren't imaginary in the sense that they don't exist. They're imaginary in that they're not a part of the standard set of numbers called the real numbers. In that event, this sort of number behaves much like you would think it would. If I is equal to this root negative 1, then if you square that, you obviously get negative 1. If you do it again, you get negative 1 times the square root of negative 1, which is minus I. And if you do that again, you get minus the square root negative 1 times the square root of negative 1. That's minus 1, which is just 1. And you're back to the beginning. What it says is that the system is actually kind of what's called cyclic, in that every four steps it repeats. So the fifth one, the fifth step, it goes back to I to the first power, and so on. So with this in mind, you can find actually any power of I, because it just repeats every 4 steps. So all you really need to do to find what the value of I to an integer power is just take the exponent and divide it by 4 and see what the remainder is. If the remainder is 1, then that's I to the first. If its remainder is 2, 3, or if it goes in evenly, the remainder of 0, then you get 1. So I to the 47th power is just, well, what should that be? That should be the same as, well, let's see, what is 47 divided by 4? Let's see, 4 goes into, 4 goes into 48 evenly. That means it goes into 44 evenly. So it goes in 11 times with a remainder of 3. 44, 45, 46, 47. The remainder of 3 tells me that I to the 47 is the same as I to the third power, which is just minus I.